network can be described as a set of connected states, where motion from one state to the next follows rules that resemble a Markov chain. This lesson treats the proposed torsional pump and layered lattices as a mathematical model, so the focus is on transitions, flow direction, structure, and the meaning of lifting a pattern into more layers. The key idea is to understand how a one-way cycle can create directed motion and how adding alternating lattice layers can spread that motion through a larger system. A Markov chain is a model in which a system moves among states, and the next state depends on the current state rather than the full path that came before it. In a torsional pump model, the states can be arranged around a cycle, so each step of the chain pushes the system from one position to the next around a loop. If the chance of moving forward around the loop is stronger than the chance of moving backward, the chain has a preferred direction, much like a wheel that tends to turn one way. Directed current in a network means the net flow along connected states is not balanced, so more motion travels in one chosen direction than in the opposite direction. In the image, the labeled points around the ring represent states, and the curved paths represent possible transitions that can combine into a total directed current around the cycle. When the total directed current is greater than zero, the model describes a system with a non-zero one-way flow rather than a perfectly reversible back-and-forth shuffle. A lattice model is a repeated pattern of nodes and connections, and it is useful because complex motion can be studied by looking at how local connections repeat across the whole structure. A two-layer lattice places two connected networks on top of the same pattern, so transitions can occur within a layer and also between matching or neighboring positions in different layers. A five-layer alternating lattice extends that idea by stacking more repeated networks, with different connection patterns alternating from one layer to the next. In the proposed model, alternating hypertoda and hyperkagome style layers means the system switches between two kinds of connectivity, one emphasizing chain-like coupled motion and the other emphasizing triangular or corner-sharing network paths. Dimensional analogy is a way to describe a simpler object as if it were lifted into a richer structure, such as describing a flat grid as part of a layered three-dimensional network. Here, dimensional lifting means moving from a two-layer description to a five-layer description, so the same one-way torsional drive is distributed through more pathways. This extra layering can be interpreted as an offset to expansion, torsion, and tension in the model because the rotational effect no longer has to be carried by only one pair of layers. The idea is mathematical rather than a confirmed physical machine. The model says that a biased Markov cycle supplies direction, the lattice supplies structure, and dimensional lifting supplies additional routes for spreading stress and motion. So the final interpretation is that the proposed five-layer alternating lattice acts as a higher dimensional network model for distributing the directed current of a one-way torsional Markov pump.